Hey, welcome to my channel, the study guide. Today I'm going to discuss about the very important subject in engineering, microprocessor and microcontrollers. So, firstly, I'll be today discussing about the introduction of microprocessor. Then, in the next videos, I'll be discussing different type of microprocessors with their architecture, coding, and all. And then later on, I'll be starting about the introduction of microcontroller and different type of controllers. Okay. So part by part we will be learning and we will be even discussing the things. So microprocessor is a multi-purpose programmable clock driven IC or integrated circuit. Multi-purpose because it can be used in various sectors for the various applications, and programmable means it is different from the calculator. Like in calculator we only calculate, but we can't manipulate any of the data which we are inserting at a time. But in microprocessor it's programmable. At a time we can even manipulate by through some programming, that's assembly language programming, and we can manipulate the processor and we can make it a programmable one. So microprocessor, it's something different than the calculator. So n number of times we can program it. And clock driven means we can give the particular frequency of the operation through some crystals. So that I'll be discussing in a brief whenever I'll be discussing different type of processors. So for now, clock driven means it gives its necessary frequency for operation. So it's a VLSI IC, very large scale integrated circuit for the large scale operation. Large number of transistors, here the number of transistor will be more, so the feature of the processor also will be more. It's an electronics device, so large number of transistor means large number of features. And here I have mentioned some applications like measurement of electrical physical quantities, monitoring, controlling, protection of any process control system, servo control system, power system, etc. So for the controllable purpose, to make a system totally controllable, we can program a processor and we can implement in that system to make it totally controllable. So here is the basic application of microprocessor. Now the next part is evolution of microprocessors. Okay, so Intel in the year of 1971 firstly developed the 4004 LSI technology microprocessor, that is the first 4-bit processor. Here 4-bit signifies this processor can handle a 4-bit data at a time, and the number of transistor was 2300. Now in the year of 1972 the first 8-bit processor Intel has developed, and with number of transistor 3500. Now this 8008 8-bit processor is having 18 pins, and the previously 4004 processor has 16 pins. So here you can see the number of transistor is getting enhanced in 8008 from 4004. That means the features is also increasing. So number of transistor more, features are more, number of pin also are more. So in 1974, the first general purpose means for each and every sector we can utilize it and we can program it for n number of times as per our convenience. So that kind of general purpose 8-bit processor 8080 firstly developed by Intel in the year of 1974 with number of transistors 6000. Then again they proceed towards the more development and they developed 8085 processor with more number of registers, instruction sets, and different assembly language coding facilities with number of transistors 6500. So features are more, so you can even see the features is increasing with the increasing number of transistors. In the year of 1978 they again developed one 16-bit processor. That means previously 8085 8080 or 8008 8-bit processor, that means they can access 8-bit data, 8-bit digital binary data 1 or 0 at a time. But now 8086 is a 16-bit processor, so it can handle 16-bit data as a time, or it can address 16-bit data as at a time with more operating speed. So as long as I'll be discussing in a brief about the 8086 8085, then you will be understanding how the operation or execution speed is more in 8086 with respect to 8085. And now hence the number of transistor is now 29,000. So you can see the number of features are more, even if in 8085 and 8086 both are having same number of pins, that is 40 pin, but in 8086 some dual performing pins are there. So one pin can be performed two tasks in different clock periods. So by in that manner, even if the number of pins are 40 as 8085, the features are more and number of transistors are also more. So now in the recent year, the dual core processor has been developed by Intel, that is E8500, with the number of transistor 410 million. It's a 64 bit, so it can handle 64 bit data at a time or address. Number of pin is 775. So now you can even think about the number of features it has. So till now the Intel is developing it, the feature of the microprocessor, so that we can have more and more features in a single IC in a very large scale manner, and we can implement it in different application sectors, in electronics, in electrical, in computer science, etc., so that we can make the system controllable as per our convenience. Now in the introduction part, this part is more important to discuss. So this is a schematic block diagram of a generalized microprocessor. Okay, so this is the processor unit. Okay, so processor unit is consisting of ALU, registers, timing and control unit. ALU means, you know, arithmetical logical unit. So this unit can perform different arithmetical operations like subtraction, division, multiplication, addition, etc. And logical operations, that is also, you know, it's like OR, AND, NOR, NOT, XOR, etc. Now again the microprocessor is having the register section. It's a kind of memory but not a memory. So in different microprocessor, different kind of registers lengths are there. In 8085 or in 8-bit processor, the length of registers are different. In 8086 it's different. So that differently we will be studying in the next videos. So for now only you need to know about the registers. Those are the temporary memory. So during read or write operation, that is data, processor is taking data from the outer peripheral, or it's sending the data to the peripheral. So that read or write operations, the data can be stored in register. So that can be accessible by the processor also, that can be accessible by the processor and user both. So we will be using some coding to access those registers. And the timing and control section is the most important part. So the timing and control section, it supervises actually the operation by the microprocessor. Like in a particular time period, as it's a clock driven, I said before. So for a particular time period, the processor maybe will be sending some data to an output device. Okay, just say, so at which time it will be sending the data. So those total process will be controlled and supervised by the control signal. This control signal is being generated from the timing and control unit. Okay, so we will be learning these things in a brief. So in architecture part or in the operative part of each and every microprocessor, we will be learning about this timing and control unit part, and that is very, very important. Okay, so ALU is for the arithmetical logical operation, registers for the data storing or data retrieving purposes, and timing and control unit, it supervises the total operation, like taking the data or sending the data. Now this part is the input output device and the memory part. The memory part is consisting of ROM and RAM. ROM means, you know, read only memory, and RAM is random access memory. So these parts are excluded or external part of the microprocessor unit. Okay, so those parts are not included. So obviously to connect this input output or the memory devices with the processor, we need some communicating wire. So for that purpose only 3 types of wires we will be studying, and in our technical term those are termed as system buses. Okay, system buses is consisting of 3 type of buses. Address bus. Address bus is to locate the address. Maybe I am sending some data from processor to the memory, supposedly. So firstly I need to know the address where to send. So that address will be located by the address bus. Next is coming the data bus. The data bus is the, at that address I need to send the data through the data bus or the data wires. And the control bus is nothing but it will totally supervises the operation. So firstly the control and timing unit of the processor will be selecting the memory, then the address bus will be selecting or indicating the address, like where to send the data, and the ultimately data bus will be carrying the data to send at the particular location of the memory. Same thing will be happening if I want to send some data to the output device, or I need to take some data from the input device or from the memory. So from memory we can take the data or we can send the data. From input device, the processor will always take the data, and to the output unit, processor will always send the data. So data sending from the processor to the other devices, these input output devices are known the peripherals and the memory. So those sending process is known as write, and some data is taking to by the processor, that process is known as read. Okay, and through the communicating wires this process has been done, those are known as system buses, and system buses is consisting of control, data and address buses. Control bus totally selects the memory or the output or input device with whom the processor is going to communicate. Then address bus will select the address, and data bus obviously carry the data to send to that particular location. So this was the brief or introduction part of the processor, like how it works. Now it depends the size of the address bus, size of the data bus, those things depends processor to processor. We will be discussing in brief about the processor. So today I am only uploading this introduction video. Please let me know if you have any query, or please subscribe my channel to tune for the next upcoming videos. Trust me, you will be learning very well, you will be understanding, and you will be able to do any kind of coding in microprocessor up to 64-bit. I'll be starting from 8-bit and I'll be ending with 64-bit and then controller also. Thank you so much. Thank you.